Okay, so let us continue with our next topic of the Laplace transform. So we will discuss about the inverse of Laplace transform, and then we discuss about the property of Laplace transform. Okay, so here is the inverse of Laplace transform. You can see here. So Laplace transform, this is what we familiar with last time. We have a function, and Laplace of this function will be equal to all of this value, okay, equation. All right, and then after that, from here we can, if the we want to get back the, let's say we have the equation of Laplace, and then we would like to find the original function, so we can use the inverse Laplace, so something like this. Okay, so if we have the result of the Laplace is like this, so inverse Laplace will be equal to this one. So here same. Okay, so inverse of this n factorial divided by s exponential n plus 1 will be n t exponential n, etc. Okay. Okay, and then this one. All right, let's see. So find the uh, inverse Laplace of 8 divided by s. So we have 8 l minus 1 divided by s exponential 0 plus 1. So it will be equal to like this. So you can see here, maybe you can have a question like why 0 factorial here is equal to 1. Okay, any question about this one? So it could be like this. So we have x, let's say x factorial is equal to x multiply with x, sorry, so it will equal to x minus 1 factorial. Is it possible? Right? So okay, so like this. So this, we, how about if we get x minus 1 factorial is equal to x factorial divided by x, correct? So let's say x is equal to 0, let's see, x equal to 1, sorry, is equal to 1. You can test by yourself. X equal to 1, so now we have 0 factorial is equal to x equal 1, so now it's 1 factorial divided by 1. 1 factorial equal to 1, so now 1 divided by 1 is equal to 1, right? So that's why it's 0 factorial is equal to 1. So 0 factorial divided by s exponential 0 plus 1, and then back to our table here, you can see here this one. So this one will be 0, so this one will be 0, so this one will be 0. So that's why inverse Laplace of this 0 and 0, it become t exponential 0, c exponential 0. This one will be 1. So so that the exponential the inverse Laplace of 8 divided by s is equal to 8. Okay. Another one, we have 25 divided by this, so 25 is out, and we have 1 divided by s square plus 4 square, right? This is 4 square, right? 4 square. So we have 25 divided by 4. Let us multiply 4 inside, because 4 here, we can multiply. Okay, let's do it properly. So we have we start from here. Okay, we start from here. So we have 25 divided by 4, multiply with 4, multiply with Laplace. I prefer this number, this. So we multiply with this Laplace, inverse Laplace of, okay, 1 divided by s square plus 4 square. Okay, so now 4 can get in, so we have 25 divided by 4, and then inverse Laplace of this 4 will come in, so 4 divided by s square plus 4 square. So what is this? Back to our, can we have this one? Sorry, can we have this one? See, 4 square and s, so it become sin 40. Okay, so that's why it's equal to 25 divided by 4. This one becomes sin 40. Okay. Okay, so now we continue with the Laplace transform of property 3. Previous time in week 9 we study property 1 and 2. Okay, so now we move to property 3. So this is Laplace transform of integral. Okay, so if you have a function f is a well-defined function over 0 to infinitive, such that the Laplace transform of s of f t to s exists from for s greater than c, then we have the Laplace of integral of 0 to t of f dou d dou t to s is equal to 1s divided by 1 divided by s of Laplace of the Laplace transform of f t to s. Okay, okay, so it sounds complicated. Let us see the example. Okay, so use the property 3 5 above to find the function ft such that f Laplace of f t to s is equal to 1 s square multiplied with s square plus 1. Okay, alright, so this one, first we observe that we can solve this problem by writing by writing this one. So this the result of the Laplace is like this. Okay, so first we have the Laplace like this. Okay, we have Laplace result like this, and then we would like to get back the f. Okay, we would like to get back the f. Okay, first we observe that we can solve this problem by writing 1 divided by s square multiplied with s square plus 1 in partial fraction, but we will use property this one we did solve in week 9, right? In week 9 we can solve this one by partial fraction, so we can try a, b, and so on. Okay, we try to separate this one into a divided by s square plus b divided by s square plus 1, etc. Okay, but this time we won't use that method, and we don't use method, we try the new method. Okay, we try the new method. try the new method, which is the property tree instead of. Okay, so by using the new method, we are going to use the, okay, so we use the Lagrange of gt. Okay, this is another function. This is another function which is extract from this function, from this. Okay, so it's equal to 1 divided by s multiply s squared plus 1, right? Okay, you can see here, so we can have 1 divided by s multiply with s squared plus 1. Okay, plus 1. So from 1, so from the table of Laplace transform, we have L sin, okay, if we have this form 1 divided by s squared plus 1, this is a sin, right? So now this is a Laplace of g is equal to 1 divided by s multiplied with the Laplace of sin t. Okay, so and then sin t, and then it's equal to, okay, so sin t is equal to what? Okay, you can see here 1 divided by s Laplace sin t to s, so it will be this form, right? You see there, 1 divided by s Laplace of function t to s, so it's equal to Laplace of 0 to t f dou d dou of t to s. So it will be this function according to theory 3, property 3 is equal to Laplace of integration from 0 to t sin dou d dou of t to s. Okay, so we have okay, so now we do the integration of this sin. So integration of sin is minus cos. Okay, minus cos, which is cos dou is equal to dou from 0 to t. Okay, so we have Laplace of, okay, and is normal, so t minus minus cos t, I mean minus 0 here, so it will be equal to, okay, this one. Okay, so we will have minus cos t minus cos minus minus cos 0. Okay, cos 0 is 1, this is 1, so 1 minus and minus is plus, so that's why minus cos t plus 1. Okay, minus cos t plus 1, right? So we may choose the following, that Laplace of ft is equal to this one, is equal to 1s, okay, 1 divided by s, okay, and a Laplace of 1 minus cos, correct, and then another one, correct, because now it's a, now this is 1s Laplace, and then this is another function, correct, this is another function, so if another function, so now it's become this one. Okay, so now 0 to dou t f dou d dou, so we have, that's why 1 minus cos dou d dou, okay, and then we do it again. We do the integration from this tau minus sin tau from 0 to t, so t minus sin tau. So that's why the function will be, I mean the function here is function here, this is ft, so equal to t minus sin t. Okay, so we will go to property 4 after the break.